Okay, this problem is slightly different in that it has a x squared in it. But again, it doesn't matter what's inside the radical. Your first priority is whatever this radical expression is needs to be isolated. So I'm going to write square root of x squared plus 9, staying right where it's at on the left-hand side. I move the negative 5 across, the equal sign becomes plus 5, 0 plus 5 is 5. So again, priority 1, every single time you see a square root in an equation, priority 1 is to get that square root expression all by itself, everything else moved to the other side. Then we square both sides, and that gets me to, on this left side, x squared plus 9. Square root and square root undo each other. Whatever's inside the radical, is squared plus 9 in this case, is what goes down there. Over here, 5 to the second power is 25. Okay, the last two problems had x plus or minus something equals. Now we have x squared plus 9 equals. So to solve an x squared equals type problem, there's no x to the first power. The easiest way to do this is move the 9 to the other side. That gives me x squared is equal to 16. And then we square root both sides. Notice this says square root of x squared plus 9 equals 5. We squared both sides. This says x squared equals 9. We're going to square root both sides. And this time I'm going to put the square root on myself, so I have to put a plus or minus there. So x should equal either plus or minus 4. Alright, and again, those represent my answers to this problem. Now, whether x equals positive 4 or negative 4, x squared is equal to 16. So if I'm doing this check, notice x squared is in my problem. So instead of putting positive 4 and squaring it, and negative 4 and squaring it, just know that both answers lead to the same x squared value. So if I put 16 right here, I'm actually checking both answers. So I get the square root of 16 plus 9 minus 5 is supposed to equal 0. 16 plus 9 is 25. Square root of 25 is 5. 5 minus 5 equals 0. So we get a true statement. Both answers are good. So those would be the solutions for that equation.